Hi everyone, I'm Mr. Van and I'm principal at Van Houston Academy, and I'm also an instructor for SAT class at Van Houston Academy. I've been doing SAT for the last 5 years, teaching thousands of students, and a lot of my students have done extremely well on the tests. Um, well, it's coronavirus, and I have to close my school. I cannot teach the SAT class, so I'm bored. So that's why I'm doing a whole bunch of series of SAT mini lessons on different topics on the tests. I tell my students that SAT is a test that you know what's going to be on there. So how do you do well? There's no magic apart from practice, but you have to practice the right way. So I'm going to go over a lot of topics that I have analyzed and the types of questions that appear in the test, and I'll show you the best approach to each of the topics. And today we are gonna go over a very simple but very common types of questions about system equations on the SAT tests. So if you have a notebook, you can take out your notebook and take some notes. Okay, so the topic today is system of equations, of linear equations. Okay, so I'm not going over how to solve system equations because I think it's pretty easy and everyone, uh, most of my students I taught, they know how to solve system equations. I'll go over the types of questions that I see on the test that most students struggle with. So let's go over an example real fast. Example one. Okay, what is that? So how do I get rid of that? Okay. Okay, so example one. Okay, so let's look at this system equation real fast. 3x minus 2y equal to 6 and 5x plus ky equals to 7. Um, so the type of questions like this, they don't ask you to solve because solving is easy. As you recall from Module 1, you learn how to do elimination, but on the test, if they ask you to solve or find the x and y, you can just plug them in. However, they make it kind of more challenging. So the type of question they ask will be, so find k so that this system has no solution. And you will see this kind of questions a lot on the SAT, regardless of the system, quadratic or linear equation. They will ask you to find a value, or they ask you what kind of equation is this? Does it have no solutions? They have two solutions, they have one solution. And so in this case, they ask you to find K so that the system has no solution. I'll go over this simple example, and then I'll show you the real question on the SAT test. So let's recall from Module 1. A system equation, the solution means where the two lines cross. What do I mean by that? Each of these equations represent a straight line, if you recall from Algebra 1. Each of these is a line, am I right? And in order to solve this, you learn in Algebra 1, you have to graph it and see where they cross each other, or you use elimination. Now, you want to find K. So remember, if you graph two lines, there's only three cases, right? So let's do case number 1. Case number 1, if you graph two lines, it will be like this, right? They will cross each other at one point, and that when you have one solution. Okay, one solution means the slopes are different. The slopes of the two lines are different. Now, case number 2. Is, if you take a guess, it will be parallel lines. Am I right? parallel line. So there will be no solutions because they don't cross each other. And slopes are the same. And then there's last case number 3. It's when you graph two lines and they are on top of each other like this. And what happened? So if you notice, the solution is when they cross each other, but here they're overlapping each other. That means they cross each other at infinitely many points. So in this case, you have infinitely many solutions. That means the slopes are the same, slopes same, and also same y-intercept. Okay, so how do we do this? So we know there's 3 cases. You want no solution. That means you want to find the slope of these 2 lines. They must be the same. So back in the day, okay, when you learn what is it called? So when you learn how to find a slope, you solve for y and you solve for slope, right? Let's try to do that in that way. Okay, I'm gonna try to do that in that way. Okay, so I don't know if you remember this, but in Algebra 1, they taught you how to solve for y, right? So you move the x over there. So you move the x over there. So you're going to get negative 2y equal to negative 3x plus 6. And then you divide by negative 2. You divide negative 2. You divide negative 2. So here, as you notice, you have the slope is 3 over 2x minus 3. So the slope here is 3 over 2. Okay. And then the second equation, 5x plus ky equals to 7. Okay. So same thing. So we got ky equals to negative 5x plus 7, and you divide it by k. You divide by k. Divide by k. So the slope is what? Negative 5 over 7. Sorry, negative 5 over k. For those of you who don't know this, the slope is the number in front of x, the coefficient of x. This is the equation in terms of y equal to mx plus b, where m is a slope. So before, the slope was 3 over 2. The slope here is negative 5 over k. You want them to be the same slope. So what we do? We set them up the same, right? So they must be the same. So it's 3/2 equals to negative 5 over k. And then we cross multiply. We got 3k equals to negative 10 divided by 3 divided by 3, and k equals to negative 10 over 3. Okay. Now, that's a very long way to do this, and I don't recommend you do it. I just show you, like in Algebra 1, that's how they taught you how to do it. But on the SAT, that takes way too long and too confusing, and you might make mistakes everywhere. So we don't do it like that. Remember that the answer is negative 10 over 3, right? You can actually do this in your head. And here's the method that I came up with. Very fast, very easy, and everybody can do it. Okay, let me show you. Let me erase everything first. I'll get rid of this. Delete. Okay. Okay, so we don't do like that. Here's a shortcut. And when you see this kind of questions, do like this. Okay, so we're going to set up ratios because the slopes is the ratios of the coefficient in front of x and y, right? So we're going to set up ratio like this. So let's look at this ratio and let's look at these ratios. We're going to compare them. For the slopes to be the same, these ratio has to be the same. Let me show you. So it's going to be 3 over 5, and you want to compare to this ratio, negative 2 over k. And you want them to be no solution. You want them to set them equal to each other. Am I right? So let's solve it like this. Cross multiply, cross multiply. So you got 3k equals to negative 10 divided by 3 divided by 3. Why is it like this? Okay, delete, divided by 3. Okay, so again, k is equals to negative 10 over 3. And that's your answer. Isn't that easier? Okay, let's do another example so that everybody's on the same page. We're gonna do a very similar example. So example number 2. Okay, example 2. This is the same thing. Let's say kx minus 3y equals to 10. And then you got 5x plus 2y equals to 7. Okay, so we're gonna find k so that it has no solution. How do we do this? We're gonna do the same thing, okay? We're not gonna solve for y, we're not gonna go the long route, we're gonna go the short route. So this is your ratio, and this is your ratio right there. So is it gonna be k over 5, and you wanna compare to negative 3 over 2. So you want them to be the same because there's no solutions. Remember, you want the slopes to be the same because the two lines are parallel, like this. So we have a ratio. What we do? Cross multiply. We cross multiply, right? So what is this? 2k equals to negative 15. So we have k equals to negative 15 over 2. And that's how you solve this. Now that's an easy example. Let's make it a little bit harder. So let's do an example number 3. Okay, so what is this? Let's say you got 3x equals to negative 2y minus 5. Okay, and we got 6x, okay, minus ky equals to 10. Okay, we're gonna ask you the same question. So find k so that the system has no solution. Okay, how do you do this? Now, in order to use the method I show you, remember we have to set up the number in front of x and y. But notice here, the equal sign is right here. The y is over here, the x is over here. So what you need to do first is you're going to move the y to the left side. So let's do this, 3x, okay? You want to move the y to the same side as the x. So when you move the sign, you need to change the sign. It's negative right now. We change it to positive, so it's plus 2y and equals to negative 5. Make sure, in order to use that method, set of ratio, you need to line up the x and the y like this. Okay. Now let's do the same thing. You want to find k so the system has no solution, right? So how do we do this? Okay, so let me set up like this. Okay, and like so. Make sure you bring the sign with it. So 3 over 6, and you want it equal to 2 over negative k. Okay, so we cross multiply again. So we got negative 3k equal to 12. That means k equal to negative 4. You can do all this in your head. Okay, so that's a method. Now let me give you a generalized case, all the cases. So let's take some notes. So if given this is a ax plus by equal to c and dx plus ey equal to f. We all have 3 cases. Case number 1. Okay, so if a over d, which is this ratio, is not the same as b over e. Well, if you notice the ratios of x and y's are not the same, it means that the slopes are different. So in this case, we have only one solution. Okay, and the graph looks like this. it will cross each other at one point, okay? Because the slopes are not the same. Now, case number 2, keep changing that. So we got A over G, which is the first ratio, is the same as B over E, but not the same. Remember, not the same as C over F. That means the slopes are the same, but not the same as the y-intercept. That means no solutions. And this is how it looks. This is the graph. It will be parallel lines like this, okay? And then we have case number 3. That's when all 3 ratios are the same. Okay, so that means the slopes are the same and the y-intercept are the same as well. So what does that mean? Remember, I showed you the first 3 cases at the beginning. So this is infinitely many solutions. And then the graph looks like this. The 2 lines actually overlapping each other, like so. Like this. So those are the 3 cases. In the next video, I'm going to show you how to apply this method into the SAT test questions. For now, I'm going to sign off and see you in the next video.